Alright, hello everyone. Welcome to the Enterprise Control Language Course Introduction Overview. This of course is for the LexisNexis KSU Senior Project. Let's go ahead and get started. So the course is going to be comprised of 6 main topics, and we're going to be talking about the ECL overview and basics, the ECL expressions and operators, ECL value types, data structures, file types, reserved keywords, and then we'll get into some functional examples. The course aims to educate the general user in the basics and uses of ECL, which was of course developed by LexisNexis for use with their high performance computing cluster or HPCC technology. And we'll dive right in. So section 1 is more of a historical background section dedicated to giving the user some more information. For instance, if you want to know what ECL is, if you had to sum it up in a paragraph, ECL is a declarative data-centric programming language designed in 2000 to allow a team of programmers to process big data. This was specifically designed for HPCC, and LexisNexis uses HPCC and ECL as the core of all of their tools that they offer, and they offer several tools. And the more you go into the courses we have available in LexisNexis KSU, you will see the different tools and how HPCC is considered. If you want to know more about the history of ECL, it's very interesting. It was designed in 2000 by David Bayless as an in-house productivity tool, and was considered to be a secret weapon. That's because when they took it to Equifax, they saw that they could use ECL on an SQL-based process to more efficiently process something. And the exact statistics in here, it took 26 days for Equifax to run a certain process using SQL, whereas ECL could do the same process in 6 minutes. And this basically became a huge part of the reason why LexisNexis acquired Scient, and then of course they used ECL as their main ingredient. So I do also want to give some more information around ECL. Again, ECL is made for use with HPCC. HPCC is an operating system of sorts. You can get it from LexisNexis as a virtual machine and host this yourself. Basically, when you run HPCC, it creates a server for you, and you can interact with that server and the several databases within it using ECL. ECL has an IDE that is actually on the server the HPCC hosts. It's called ECL Playground. I have imaged both of these here. You see ECL Playground here, and in the background there is HPCC running on my local machine. Of course, there's more resources around ECL. LexisNexis has done a great job documenting this. There's also additional training resources for ECL that can walk you through, much like we are in this course, the in-depth and the insane intricacies of this language. It's very strong, very complex, and you learn a lot by going through this training materials in addition to what we have to offer here in LexisNexis KSU. So that's section 1. We get into section 2, which of course is just a big overview of the basics of ECL. There's a lot of information in this section, and it aims to educate the user on the bare minimum they need to get started. Of course, we'll be talking about things like definitions versus actions. These are 2 different types of ECL code. We'll go into that. Some syntax notes. For instance, ECL is not white. It doesn't acknowledge white space, much like Python or things like that. You have constants. Oh, excuse me. Python does acknowledge white space. You have constants, things like strings and numerics. We'll talk about those. Of course, you have definitions and how you define things. We'll talk about naming conventions, reserved keywords. Talk about filtering. Filtering is a huge piece of ECL, considering it works with databases. So filtering is a big piece to talk about in the overview. We'll talk about some basic definition types, your booleans, your values, your sets. We'll talk about all these. Then we also talk about functions, how you declare functions, the various parameters. We'll talk about visibility in code, such as global, module, local, and then we'll also talk about some debugging strategies. And again, all this is very high level, just an aid to help you get started. Within all these, we include the LexisNexis training materials to add further support. So section 3 is going to be the ECL expressions and operators. We separated into 3 main subsections. That's going to be arithmetic operations being 1, And this, just like with many other languages, you have your division, your modulus division, your multiplication, addition, and subtraction. You also have error handling. We'll get into that. There's special ways to handle dividing by 0 and infinity. Like LexisNexis saw a need to have an ingrained way to handle dividing by 0 and what you could do when that happens. It's very interesting. We'll get into that. The second section of ECL expressions and operators will be bitwise and bit shift operations. Now, bitwise operators, everyone's familiar with them, and or exclusive or not. And then bit shift operators, not everyone is so familiar. You have your bit shift left and bit shift right. We'll get into how ECL works with both of those, and we'll explain what they do and how their importance is conveyed throughout the code. So the last section of ECL expressions and operators is logical operators. This is things that you use for logic, and you have, of course, not, and you have the shorthand not, and or. You can also make an XOR logical operator, and ECL again thought this is a very useful item, so they included a tutorial on how to do this, so we'll include that as well. Then you also have things dealing with record sets, and sets are a very big part of ECL. We'll get into that later, but they have logical operators built into the language to deal with sets. So you have prefix, combining, and subtracting operators for sets. We'll talk all about that later. So section 4 is going to be all about the value types. And see how I attached a screenshot, and this is a 2-page item, but this is the first page here. I attached a screenshot of myself declaring a few different the value types. So first we have here a Boolean, and just like with all Booleans, you're going to declare a Boolean, and then you're going to give it a Boolean attribute. Some attribute is less than 10. Basically, if it's less than 10, you're going to get a true. If it's greater than 10, you're going to get a false. So that's how that's working. Of course, then you have integer 1. And the reason that 1's there is because there's different classes of integers. We'll get into all that later. And we call this variable myInt. And please take note of how you are actually declaring things. It is as a colon equals. No equal sign here. You need to use the colon and the equal to define an actual variable. So this right here is declaring an integer to my value. Then, of course, you have real numbers. Real numbers are different than integers. And again, this is a real 4. There's a real 1 through, I believe, 7. We'll get into all that later. And this is my real, and it's being declared to a 1.0 or a 0. We'll get into the differences between these here. You have a decimal, 2, and then 5 total digits with 2 decimal places. That 2 dictates how many decimal places will be included. That goes all the way up to, I believe, 9. Of course, you have strings. This declares my string to ABC. Very basic here. And then you have a Q string. Now, a Q string is very interesting. It just reduces your byte size. So this is a Q string 12. But you see here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 letters. But it's only going to use 9. And we'll get into why that works later. So let's go to 2 here. So then you have Unicode, and then you put 16 here. Now, of course, that refers to UTF-16 encoded string. Now, that goes to for all the UTF, so that 16 just declares which UTF you want to use. You put that U in front, and then you define what you want the string to include. So again, we'll go down to the next one. That's data 8, and again, that 8 is a part of a larger table. It goes from 1 to, I believe, 10, and that's an 8-bit data block. That's what the 8 stands for there. And then you have hex values 12, 34, 56, 78, 90, blah, blah, blah. That is, sorry about that. That is referring to what you're actually declaring here. And we'll get into more detail about all these. Just want to give everyone an overview. Then you have a variable string, my string ABC. Now this is going to declare a my string right here, a 3-byte null terminated string. We'll get into what that means. It's very interesting, but it's very useful also in ECL. So another thing, sets. I had mentioned before, sets are very useful in ECL. Here we have set of, and if you make a set of integers, set int ones is the name of the set here. And then you declare it much like you do an array. This is creating an array of integers. Set of is synonymous with array. It has different properties, but it's doing the same thing. And again, here's another example. Set of string ones is the name. String one refers to, like we mentioned before, string one, string class one, and then you have different characters right here, and that is making a set of string ones. Again, much like an array, and you could reference these much like you do an array as well. So the last value type we're going to talk about is the type ofs. You have string 3 Fred. Declared Fred as a 3-byte string. So basically, we have declared Fred as a 3-byte string. The next line down says type of Fred Sue equals Fred. So we just declared Sue as Fred. It's basically making a duplicate of something. You have to do it like this. This is how you can't just reference the variable. You couldn't just say Sue colon equals Fred. It doesn't work that way. You have to do a type of statement. So it's very interesting. We'll talk about more about all of those in the section later. So section 5 is a very dense section. I have condensed it here just for readability, but ECL data structures and file types. You have record sets, you have data sets, you have dictionaries, and these are just some. There's some other lesser used file types and data structures. So these are the ones I wanted to focus on. A record set basically declares what you want a table to look like. It's, for instance, you see here you're saying unsigned, and it's going to be SIC code, and that could be read as zip code. String 120 company name. You're saying you want a string here, and it's going to be company name. It's much like what? So section 5 is going to be ECL data structures and file types. This is a really dense section. I managed to condense it down at this slide just for readability. But of course you have 3 basic types of data structures in ECL. You have records, data sets, and dictionaries. They all behave differently. They all serve different purposes, but they all work together. A record structure is basically defining the layout of what you want a database to look like. For instance, this is the layout for a company, and this is how you're going to define a record as well. So you have layout underscore company equals record, and then you define what that layout looks like. So you're giving it the value type, and then you're giving it a name right over here. We just went through all the value types, and these are mostly using strings, and then you're naming it. And when you're using a data set, you basically take a set of data and you plug it into the record. So if you have a data set that uses these names, you can plug those names into the record by using something like this. You export the data set using this record. And again, a record is basically a layout, while data is actual content. Dictionaries behave a little differently. Dictionaries allow you to define more complex records and different types of layouts. They're much more complex. We'll get into those later as well. Let's move on. Section 6 is all about reserved keywords. I didn't want to go too in depth here, but these are all the different reserved keywords. We'll talk about every single one of these in depth, how they work, and how you can use them within your ECL code. Section 6 is going to be all about functional examples. This section is dedicated to providing walkthroughs and video tutorials for various functional tasks using ECL. I won't get into these right here. You'll be able to go to section 7 and see these for yourself. And then you can use those to operate your own ECL. So it'll be much like tutorials for all the different things you can do. And besides that, that is the end of this course overview. Feel free to download these slides. Again, they will be available. You can use all the links, and you will be able to access everything that I had access to build this. Besides that, see you later.